For number 12, I'm going to erase a little bit of this old work. For number 12, we're doing another subtraction problem, just like 11, except this time they're not like terms, mostly because we haven't simplified them yet. So let's do that. 18 will break down into 2 and 9, which breaks down into 3 and 3, and there's a pair of 3s that are going to pop out front with a 2 staying behind. Okay? The pair of 3s come together when they come out, they get square rooted, and we get a -9 square root of 2. That square root of 2 is because that got left over. 8 breaks down into 2 and 4 and 2 and 2. There's a pair of 2s. You could also circle the bottom pair. But either way, you get a 2 left behind. When that pair of 2s comes out, it slams into whatever is out front, giving us a -6 by multiplication, square root of 2. And now, guys, from the beginning, we looked like we couldn't combine those. But we can see now that they are like terms because this is a square root of 2 and a square root of 2. When they have the same exact thing under the square root, we can combine the numbers out front. When we do that, -6 and -9 combine to be a -15 square roots of 2. Okay? Number 13, it says compare number 12. We see that it is a subtraction problem and a multiplication problem. They're the same numbers, but we're going to get different things because we're doing a different operation. For multiplication, you can simplify first if you'd like to, but also you can just multiply from the get-go. What I've droned on about with these problems is when you multiply outside numbers by outside numbers and inside numbers by inside numbers. And this is what I mean by that. Outside numbers being numbers out front and inside numbers being things under the radical. Okay? Outside times outside is -3 times -3, which is 9. Inside times inside, 18 times 8 should be 144. Let's do a little calculator check. That might have been a little bit hasty. 18 times 8. Okay, 144. And you sit there and go, okay, done, multiplied. No, go all the way back to the original directions in the section, and it says simplest radical form. Well, 144 is definitely going to simplify. Now, you can break it down into 2 and 2 and 2 again and again, but I know my times tables. I know that 144 will break down into 12 and 12, which actually means 144 is a perfect square. Okay? So from right now, you could just square root it, pop it out, and multiply it, and call it a day. But let's go ahead and work it out just to be safe. When we break down into 12 and 12, now you can go a bunch of different ways. We can break down into, 3 and 4, or 2 and 6, maybe another 2 and 6, which breaks down into 2 and 3, which breaks down into 2 and 3. This is why this gets a bit messy when you don't just choose basic numbers, when you choose a 12 and 12, because our tree is now a lot of stuff to pair up, and it's hard to see. There's a pair of 2s. There's a pair of 2s. And look here. We have a pair of 3s. It doesn't matter they're not next to each other. It's still a pair of 3s. Double check to make sure you didn't leave anything behind. Look at the very tips of the tree. Everything's accounted for, and everything's coming out. That's because 144 is a perfect square. When everything comes out, they come out as a single item, and they multiply by whatever was out front. What that means is we had a 9 out front. We're bringing out a 2. We're bringing out another 2. We're bringing out a 3. And we're actually leaving nothing behind. So our final answer is 108. There's nothing left in the square root. Okay? 14 is a similar problem. For 14, we're still doing a multiplication problem. So we're going to multiply outside by outside and inside times inside, but this first piece does not have an outside number. I would encourage you that if you are still struggling a little bit with this on the review day, to rewrite this problem so that everything has an outside piece and an inside piece. What that means is right here where we're missing an outside piece, you have a 1 on the square root of 5. The second but this second piece already has an outside number and an inside number, so you don't have to rewrite it. So we haven't done the problem yet. We've just rewritten it so that we can see outside times outside, which is 4, and inside times inside, which is 75. Okay, double check that. 75. Now, there is some merit and some different teachings that tell you to just leave 5 times 15 in here and then break down the 15 and pair it. I kind of learned last year that can confuse some students. So we've just been doing it this way because now we're just breaking down 75. Well, 75 can be broken down as 5 and 15. In fact, it's what we just multiplied to get it. And then 15 can be broken down into 5 and 3. So there's a pair of 5s, there's a 3 I left behind. The only reason we're doing this is because the direction said to put them in the simplest radical form, and this is simplifying, okay? When that 5 pops out, it multiplies into that 4, and we get a 20 square root of 3 as our final answer. On number 15, this is more radical work, and it's more radical multiplication, but namely, this is distribution. So it's got to be multiplied by both pieces. Again, if you want to, it'll help you with your consistency. Rewrite the problem so that everything's where it should be. 1 on the square root of 10n, that way I have an outside and an inside, times 1 on the square root of 2, plus 3 on the square root of 6n. Didn't have to mess with that last one. It already had an outside and an inside. Now I'm ready to multiply. This first arrow, I do outside times outside, times error. And then I do inside times inside, which is 20n. For my second arrow, I do outside times outside, which is plus 3. And then inside times inside, which is 60n squared. 10n times 6n is 60n squared. Well, I don't know if I can add these together yet. I've got to first simplify them. To do that, I've got to break down the numbers. 20 breaks down into 2 and 10, which breaks down into 2 and 5. The 2 comes out front. The 5 gets left behind. Also, the n gets left behind. Be careful there. Don't forget about it. When that 2 pops out, it slams into that 1. 2 times 1 is 2. We left behind a 5n. 60 is a little more complicated. It breaks down into 6 and 5 is the first thing that most people, or not 6 and 5, but 6 and 10 is the thing most people go to. I'm a simple man. I like to choose 5s. 5s make sense to me. I knew 5 went into 60. Like immediately, I just knew it. Well, and that breaks down into 5 and 12 because that's my times tables. 12 breaks down into 2 and 6, which is 2 and 3. Now I've got a pair of 2s that are coming out. And I've got a 5 left behind and a 3 left behind. I'm going to have to put those back together. N squared is n times n. That's a pair of n's, and they're going to completely come out front. The result is 2 times 3, which is 6 n. And then I have a 3 and a 5 left over. I multiply those back together and get 15. Now I can see I can't break down 15 anymore. It'd be a 3 and a 5, which don't come out. Can't break down 5n anymore. And these are not like terms, so I cannot add them. Therefore, that is indeed my final answer. Okay? Number 16 follows suit very carefully. -3 square roots of 5 times 1 on the square root of 5 plus 2 on the square root of 1. So this time I didn't have a square root. I fixed that by having a square root of 1 there. When I multiply, I get -3 on the square root of 25, outside times outside, inside times inside, and I get -6, outside times outside, on the square root of 5, because 5 times 1 is just 5. 25 can be broken down into 5 and 5, which pops out front and leaves nothing behind. Therefore, I have a -15 all by its lonesome, and then this doesn't simplify. 6 on the square root of 5 doesn't simplify. So we just leave it. Leave it as is. Okay? You just have to leave it just like it is. 6 on the square root of 5. Don't overmath these problems. If they don't combine, they don't combine. But you have to simplify them so that you can tell.